Beautiful. We okay? Yeah. Alright, so let's rewrite it. So we end up with 2 minus sine of 2x plus, oh, just kidding, minus 2x cosine of 2x. We had to do chain rule on that one, right?
Yep.
Derivative of the sine times the derivative of the 2x. You're confused? What?
Say
No,
it.
yeah, I got it.
Say it.
Got it?
Yeah.
Say it. Keep going.
Alright, so go ahead and type that equation into your calculator. And how are we going to know, how are we going to explain how the second derivative confirms our response to question 2? How are we going to know that we truly have 5 points of inflection? What's going to happen on the graph of the second derivative?
We're gonna go from
Wait,
it's gonna change from
3 raised
below to
to
above.
So h double prime of x
No.
has to equal to 0, but it also has to what? Change what? It has to change signs in order for the original function to having what? No, a point of inflection, right? Okay, so how do I know if a graph is changing signs? It's going from where?
Below to above, above and below.
Very good. So it goes from above to below, the x-axis, or vice versa. So graph this bad boy, and let's see what happens. Does it cross 5 times?
Yep.
2 minus sine of 2x minus 2x cosine 2x. Am I missing something? The times between the x and the cosine. It'll pick it up between the 2 and the x, but not the other way.
Oh, yeah.
Good? So how many times does the second derivative go from being above or below the x-axis? 1, 2, 3, 4, 5. So there was 5 times where it switched, right? So that means that there has to be truly 5 what? Points of inflection. Do you understand? Yes? The second derivative changed signs how many times? 5 times. So let's write the explanation. H double prime of x changes signs how many times?
5 times.
5 times. Therefore, h of x has what? Points of inflection. Good? Papitas? Yeah, we could have been more specific and we said h double prime changes signs 5 times on the interval -5 to 5. Therefore, h of x has 5 points of inflections on -5 to 5. We wanted to be more specific. Cool? We're not looking at the entire graph, we're only looking at that part. It would be important, it would be good to put on there. But I mean, I don't think they would be that strict. I don't know. Better to be safe than sorry, right? Have that extra information and it won't hurt anyone. It's kind of like when you write points of inflection, just write the whole point, the x and the y. Rather than just write the x and then they were asking for the point, then you didn't give the whole point. Same thing with relative extrema, write the whole point rather than just the x value. Cool? Alright, are we good? Any questions? You ready for the assignment?
like 10.
Let me give you a question number.
And then I'm not good. I know, Mr. says, is this also the assignment?
If you can go.
Just square.
That's not funny anymore.
It's not. It's like it's not. Yeah.
No one knows about
Alright, so let's say I give you this table up here. Okay, what is this table describing? What derivative?
First derivative.
First derivative, right? So what can you notice right away if I'm giving you the first derivative? Increasing, decreasing, relative, max or min, right? Okay, what if I asked you, where does f of x, or what are the critical values of f of x? What would you tell me?
5.
Negative 4, and 2? Why negative 4, negative 1, and 2? Very good, excellent. So if I made a sign line for this table, what would be on my sign line? Negative 4, 1, 2. Okay. What would be the signs on the left of negative 4? Negative? Why negative?
Because the next number is.
Very good. Okay, that would be like me picking a number, plug it into the derivative, and I would get what kind of an answer? Negative. That means that my original function is what? How about between negative 4 and negative 1?
Positive.
Positive, that means my original function is increased. How about between negative 1 and 2? Positive? And how about beyond 2? Negative. Okay. So now could you just tell me the intervals where the original function is increasing? Negative 4 to 2? Ah, you gotta split it up? Why do you have to split it up?
Because.
That negative 1 is what? 0, right? It's not increasing or decreasing. Awesome. Good. Where would I have a relative max?
At 2.
At 2, right? Okay. Where would I have a relative min? Negative 4. Got it?
Yes.
Good job. Sometimes on the AP test they give you questions like that. Right? So you can't panic. Good? So have your notes out with you so you can see how the derivatives are related to help you answer the questions, okay? And that's it for today. So we have about 20-something minutes for you to work on this assignment. Use the time wisely.
Awesome.
This is